All right, our next topic of conversation is polarization, what it is. Okay, so polarization can be used to change the movement of the electrons, and we can do that by inducing a movement of charge. So here's an example. We've got a pop can neutral, which means positive and negative charges are balanced, and they're distributed evenly throughout the can. Now, we take a balloon, we rub some fur on it and make it negatively charged, and we put it close to the can. So what happens is all the electrons that are evenly in this can right here all get pushed opposite because like charges repel. So what we see then as we hold this balloon here is that the pop can does develop a negative charge on one side and a positive charge on this side. That's called making something polar or polarizing something. And by polarizing, that means it's like a magnet. Positive end and the negative end, and that's what we get here with this pop can. If you want to try this at home, you can just use a styrofoam cup, and you can do that. Now, another demonstration that commonly see, and something we'll try to do in lab, is we will take a balloon, rub it on our hair, and we take this balloon and then we stick it to a wall. Now, what happens there is that polarization occurs. Okay, the atom of any object that we get near to with a negative charge, it polarizes where the negatives go this way and away from this charge. If it's a positive charged object, it pulls the electrons closer and pushes the positive charge away. So what we see is part of this atom becoming negative and the other part becoming positive, and vice versa here. So with the balloon, we rub fur on it. It develops a negative charge. When we stick it against a wood, wall, door, whatever, cabinet, all the negative charges get pushed away because of repulsion, and what happens is the positive charges come to the forefront and there's an attraction. Negative and positive attract, the balloon will sit there and almost appear to levitate right there on the wall. Try it and you'll see it'll work. Another example of polarization, you got water. Now water, if you recall, and you can see it here, consists of an oxygen atom and two hydrogen. Well, the negative end of the water is oxygen and the positive end is hydrogen, and that makes it polar, which means it already has a positive and negative end. So if we take a balloon and rub it on our fur, on our hair, and give it a negative charge, when we put it near a very, very thin stream of water like we have here, the water will bend towards the negative balloon. Now what causes this is the water molecules, the positive ends, so our hydrogen end, will start to pull towards that negative charge. And even though it looks like the water is magically moving, all we're doing is polarizing the water to put the positive end on this side and the negative end on this side. And in doing so, we can pull it right along. Again, something else we'll try to see if we can do in lab. Now, what's the difference between polarizing and charging? Polarizing does not change, and I'm going to say that in big letters, does not change number of electrons. We're not adding electrons or taking away electrons. We're just moving the electrons. So even though this piece of wood, and we take that negative charge balloon and put it near there, we're not adding any charge to it. The negative charges are just flowing to one side and the positive charges are just coming to the other side. So it gives the appearance of having a charge, when in fact we don't change the charge. All we do is change the distribution of charge. The electrons move, and we can have a positive and negative end, which will then cause an attraction to occur. So polarization, not charging.